Alright, so you're viewing this video because you are having problems understanding what an isotope is, possibly what a nuclide is, or how to identify the different parts of an atom using the periodic table. What we have on this slide is we have carbon-14, which is an isotope of carbon. Alright, so what that means is if you look at the periodic table, you'll notice that over here, this is an excerpt from the periodic table, this is what you'll see. You'll see that carbon has 6 protons and it has an atomic mass of 12.01. Remember what the 12.01 is. It is the average mass of all the isotopes of carbon. Alright, carbon has many isotopes. Carbon-14 is just one of the different isotopes, carbon-14, but there's also a carbon-12 and a carbon-13. Okay, so there are other isotopes of carbon, but these are the most common, and what they do is they find the mass, and you have to also consider the abundance, but basically it's the average mass of all these isotopes, and that's what this number right here represents, is the average mass. Alright, well, a nuclide is an isotope or a very specific carbon. If I say carbon-12, then I'm talking about a specific carbon atom. I'm talking about the carbon atom that has a mass of 12. If I'm talking about carbon-13, I'm talking about a very specific atom of carbon that has a mass of 13, and carbon-14 the same. Okay, so that's what a nuclide is. It's a very specific atom of an element. There are two ways that you can write or indicate an isotope. One way is like this. One way is like this, where you put the mass number on top, and I have that notated right here. Mass number on top, and then the atomic number goes on the bottom. So that would be what carbon-14 would look like. I'm going to erase that. Go back to my pen. Alright, and then this would be what carbon-12 would look like. You'd have the carbon, which is the symbol, the mass, and then the atomic number. Carbon-13, you'd have the mass, and then the atomic number, atomic number. So you see the atomic number doesn't change, only the mass does. Every one of these symbols that I just wrote here represent carbon. Alright, so if you look at the chart that I have down here, sodium, 20. Alright, so we're talking about a very specific isotope of sodium. We're talking about the sodium atom that has a mass of 20. If you look at the periodic table, you'll see that sodium looks something like this, with an 11 here and a 22.99 on my periodic table. Okay, so to find the atomic number, which is the number of protons, I look on my chart, and here it is. It's the smaller number. The atomic mass, which is 22.99, that is the number from the periodic table. The mass number is this number. Okay, I am talking about a very specific isotope of carbon, or excuse me, sodium. I want sodium with a mass of 20. Protons, again, is identified by the atomic number. The electrons, because we're talking about electrically neutral atoms, electrons are going to be the same as the proton. And then the neutrons, remember what mass number is. If you remember through your notes, mass, wait a minute, let's back up. Let's do it this way. Let's put it this way. Let's say that mass number then is protons plus neutrons. Okay, well, if we know the mass number is 20, so we have 20 equals protons is 11 plus our neutrons is what we're looking for, and we can just do a simple algebraic equation, subtract 11 from 20, and we get 9. Alright, so if it's magnesium, remember this is another way of writing an isotope. We've got magnesium 26, has an atomic number of 12, so we really don't even need a periodic table for this one. We just say, alright, it's got an atomic number of 12. Well, I guess we do need a periodic table because for the atomic mass, we have to look at the periodic table, and it's 24.31. Alright, so this isotope has a mass number of 26. It has 12 protons because the atomic number tells us that. It's got 12 electrons because of it's an electrically neutral atom. So to find the number of neutrons, so we know that protons plus neutrons equal mass number. So 12 plus 14 equal 26. Okay, so moving on your periodic table or of your PowerPoint, we have the same thing. Okay, so we have gold. It's gold 197. So that means we're talking about a specific atom of gold, and it's got a mass of 197. All right, the symbol for gold is AU. Okay, so you find gold on the periodic table, and we find that the atomic number is 79. The atomic mass is 197.0. In this case, the atomic mass and the mass number are close to the same thing. Atomic number tells us the number of protons. Electrically neutral atom, electrons and protons are the same. And then neutrons plus protons equal mass number. So you're going to subtract 79 from that, so we get 8, and that makes 8, and that's going to be 98, right? 79 plus 98 equals 197. Well, I can't do my math very well. How many of you caught my little mistake here? Well, hold on. Eraser's not working. Well, anyway, we'll just go back to the pen, and hopefully we can get this pen working. And it's not 98. It's 118. Sorry about that, guys. Okay. So let's look at the next one. The next one has atomic number 14. So what are we going to do? We're going to go to the periodic table. We're going to find number 14. So all of you look at your periodic table real quick. And number 14, hopefully you're finding, is silicon. Excellent. Let's write this silicon. Whoops. Let's do this. Alright, silicon. Alright, so the symbol is Si. Alright, the atomic mass is what we see on the periodic table, so it's 28.09. The mass number is protons plus neutrons. Well, we know what the protons are. We know what the neutrons are, so our mass number is going to be 24. And the number of electrons, because it's electrically neutral, are going to equal the number of protons, so that's 14. All right, because this is an isotope, we need to identify either in the name or the symbol that this is an isotope. So let's write it this way. Let's put the mass number up here and the atomic number down here. So this is called silicon 24. Okay, so this next one, I want you guys to think for just a minute before I give you the answer, but this has 87 electrons. All right, well, if it has 87 electrons, what does that tell you? Good. I'm hoping you're thinking, well, this is an electrically neutral atom, so that means if we have 87 electrons, we're going to have 87 protons. Well, if it has 87 protons, then that means we have an atomic number of 87. All right, now all we have to do is go to the periodic table, find number 87, and number 87 is francium, or francium, depends on who you're talking to. When we look at the mass numbers on this case, in this case is 223 on the number of neutrons. So if we take 225 and we subtract 87, or let's just say 225 minus 87, and we get 138. So we get 138 neutrons. Alright, one more to go. Alright, Mn. Mn. Alright, everybody find it on the periodic table. Mn. Alright, great. Hopefully you found this is manganese. M-A-N-G-A-N-E-S-E. We're going to need to go back up to francium because this is an isotope, so therefore we need to indicate that it's an isotope, and this is francium number 225, so we do need to put the 225 out here to indicate that it's an isotope. Alright, manganese is number 25 on the periodic table, so that means we're going to have 25 protons, 25 electrons. The atomic mass number for manganese is 54.94. I hope you can see that on that blue. And so 25 from 55 is 30. Alright, I hope this helps. If you look down here, you'll see at the bottom of this page, there's a web address. And if you go there, there's even more practice on finding atomic information. Hope this helps. Thanks.